SETI, 30 years of scouring the cosmos for extraterrestrial alien life. This month marks the 30th anniversary of one of the world's largest searches for evidence that we are not alone in the universe. Phil Edwards says in February 1995, a small research organization known as SETI Institute launched what was then the most comprehensive search for an answer to a centuries-old question, are we alone in the universe? This Sunday marks the 30th anniversary of the first astronomical observations conducted for the search, named Project Phoenix. These observations were done at the Parkes Observatory on Wiradjuri County in the central west of the New South Wales, Australia, home to one of the world's largest radio telescopes. That Project Phoenix was lucky to get off the ground. 3 years earlier, NASA had commenced an ambitious, decades-long $100 million search for extraterrestrial intelligence, that's SETI for short. However, in 1993, the United States Congress cut all funding for the program because of the growing U.S. budget deficit. Plus, SETI skeptics in Congress derided the program's far-fetched search for little green men, quote-unquote. Fortunately, the SETI Institute secured enough private donations to revive the project. The Project Phoenix rose from the ashes. And listening for radio signals? If there is life elsewhere, it's natural to assume that it evolved over a million years on a planet orbiting a long-lived star similar to our sun. So SETI searchers usually target the nearest sun-like stars, listening to radio signals that are either being deliberately beamed our way or are techno-signatures radiating from other planets. Techno-signatures are confined to a narrow range of frequencies and produced by the technologies an advanced civilization like ours might use. Astronomers use radio waves as they can penetrate the clouds of gas and dust in our galaxy. They can also travel over large distances without excessive power requirements. Mary Young, CSIRO 64-meter radio telescope at the Parkes Observatory, has been in operation since 1961. It's made a wealth of astronomical discoveries and played a pivotal role in tracking space missions, especially the Apollo 11 moonwalk. As the largest single-dish radio telescope in the southern hemisphere, it is also the natural facility to use for SETI targets in the southern skies. While Project Phoenix planned to use several large telescopes around the world, these facilities were undergoing major upgrades. So it was at Parkes that the observing program started. On February 2nd, 1995, Murray Young pointed towards a carefully chosen star 49 light-years from Earth in the constellation of naturally Phoenix. This was the first observation conducted as part of the project. A logistics and technological success. Project Phoenix was led by Joel Tarter, a renowned SETI researcher who spent many long nights at Parkes overseeing observations around the 16 weeks dedicated to the search. Jodie Foster's character in the 1998 movie Contact was largely based on Jill. The Project Phoenix team brought a trailer full of computers with state-of-the-art touchscreen technology to process the data. Bogong moths caused some early interruptions to the processing. These large nocturnal moths were attracted to light from computer screens flying into them with enough force to change settings. Over 16 weeks, the Project Phoenix team observed 209 stars using Murray Young at frequencies between 1,200 and 3,000 megahertz. They searched for both continuous and pulsing signals to maximize the chance of finding genuine signals of alien life. Radio telescopes are able to detect the faint radio emissions from distant celestial objects, but they are also sensitive to radio waves produced in modern society, our own technosignatures by mobile phones, Bluetooth connections, aircraft radar, and GPS satellites. These kinds of local interference can mimic the kinds of signal SETI researchers are looking for, so distinguishing between the two is crucial. To do this, Project Phoenix decided to use a second radio telescope some distance away from an independent check of any signals detected. CSIRO provided access to its 22-meter Morpra radio telescope about 200 kilometers north of Parkes to follow up signal candidates in real time. Over the 16 weeks, the team detected a total of 148,949 signals at parks, roughly 80% of which could be easily dismissed as local signals. The team checked a little over 18,000 signals at both parks in MOPRA. Only 39 passed all tests and looked like strong SETI candidates, but on closer inspection, the team identified them as coming from satellites. As Jill Tarter summarized in an article in 1997, although no evidence for an extraterrestrial intelligence signal was found, no mysterious or unexplained signals were left behind, and the Australian deployment was a logistical and technological success. The next generation of radio telescopes. When Project Phoenix ended in 2004, project manager Peter Backus concluded, "We live in a quiet neighborhood," but efforts are continuing to search for alien life with greater sensitivity over a wider frequency range and for more targets. Breakthrough Listen, another privately funded project, commenced in 2015, again making use of the Parkes telescope among others. Breakthrough Listen aims to examine 1 million of the closest stars and 100 closest galaxies. One unexpected signal detected at Parkes in 2019 as part of this project was examined in painstaking detail before it was concluded that it too was a locally generated signal. The next generation of radio telescopes will provide a leap in sensitivity compared to the facilities today, benefiting from greater collecting area, improving resolution, and superior processing capabilities. Examples of these next generation radio telescopes include SKA Low Telescope, under construction in Western Australia, and the SKA Mid Telescope being built in South Africa. They will be used to answer a wide variety of astronomical questions, including whether there is life beyond Earth. As SETI pioneer Frank Drake once noticed, "The most fascinating, interesting thing you can find in the universe is another kind of star or galaxy, is not another kind of star or galaxy, but another kind of life." Phil Edwards, Senior Research Scientist, Australia Telescope National Facility Science, CSIRO. This article is republished from Conversation with the Creative Commons and it's on Unexplained Mysteries. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.